The fact that you're alive at all is basically luck. 300 million years ago, the real rulers of this planet were things you couldn't dream up in your worst nightmare. A dragonfly with a wingspan of 70 centimeters, nearly 2.5 feet, wider than your face. A millipede over 2.5 meters long, more than 8 feet, long enough to stretch from one end of your bed to the other with room to spare. And your ancestor? Back then, it was just a tiny, shivering rat hiding in the mud. It didn't even rank high enough to be worth eating. Scientists have run the numbers. If these giant bugs had never gone extinct, mammals could never have risen up. You simply would not exist. But here's the part that really crawls up your spine, the very thing that killed them off. Humanity is bringing it back with our own hands. This era is called the Carboniferous. You've probably never heard the name, but you've definitely used what it left behind. Coal. That's right. The coal we burn is the corpse of those giant prehistoric forests, 300 million years old. The Earth back then was a completely different planet. The sky wasn't blue, it was a pale, hazy gray, because oxygen made up as much as 35% of the air. To put that in perspective, oxygen makes up only 21% of the air today. That extra 14% turned the entire planet into a monster factory. Here's why. Insects don't breathe with lungs the way we do. Their bodies are laced with tiny tubes, and oxygen seeps directly into every cell. But this system has a fatal flaw. The bigger the body, the harder it is to push oxygen deep inside. That's why the biggest insects today are only about the size of your palm. But in the Carboniferous, the air itself was basically a can of concentrated oxygen. The insects soaked it up and ballooned in size, growing bigger and bigger, like they'd unlocked a cheat code. And that's when the nightmare began. Start with that dragonfly. Its scientific name is Meganeura. Large-veined. A 70-centimeter wingspan was just average. The largest fossils found had wingspans close to 75 centimeters, the size of a hawk. But there's a fundamental difference between a dragonfly and a hawk. A dragonfly is the fighter jet of aerial predators. It can hit speeds of around 70 kilometers an hour, over 40 miles an hour. It can hover, it can fly backward, it can turn on a dime in midair. Modern dragonflies have a hunting success rate as high as 95%, making them the most efficient killers in the natural world. Scale that up to Carboniferous size, and you understand exactly why your ancestors stayed hidden in the mud. Meganeura wasn't picky. Other insects, small amphibians, even early reptiles, all fair game. Its compound eyes were made of nearly 30,000 tiny lenses, giving it a field of view close to 360 degrees. Almost no blind spots. Its jaws could snap shut in 0.03 of a second, 10 times faster than you can blink. Before you even registered it was there, you'd already be inside its mouth. And here's the worst part. This wasn't one or two of them. They flew in swarms. At a fossil site in France, paleontologists uncovered huge numbers of Meganeura wing fragments packed together like the wreckage of some ancient plane crash. Back then, the sky belonged to them. But as terrifying as the sky was, it was nothing next to the ground. The undisputed king of the Carboniferous forest floor, Arthropleura, 2.5 meters long, over 8 feet. Taller than almost any human is tall, laid out end to end. Its body was divided into around 30 segments, each with a pair of legs on either side, more than 60 legs in total. And those legs didn't just flail around, they moved in precise, wave-like coordination, letting this monster move at a startling pace. Based on fossilized trackways, it may have crawled at speeds up to 8 kilometers an hour, so about 5 miles an hour. That might not sound fast. But picture a bug more than 2 meters long charging at you at a light jog. Here's the interesting part. Scientists still argue about what this thing actually ate. The earliest theory said it was a carnivore that hunted other arthropods and small vertebrates. But in 2022, a study published in a geology journal found plant spores and woody fibers inside fossilized Arthropleura gut contents, meaning it was very likely an omnivore. And that's even scarier. Omnivore means it ate anything. Your ancestor hiding in the mud could dodge the dragonflies overhead, but it couldn't escape this giant burrowing centipede-like beast on the ground. Its body structure shows it was fully capable of digging through soil, dragging those little creatures that thought they were safe right out of their hiding spots. And these two weren't the only nightmares. The Carboniferous had a whole bestiary. Giant scorpions close to 70 centimeters long with a venomous stinger on the tail the size of a hand. Giant spiders. The fossils are incomplete, but based on leg fragments at least twice the size of the biggest spiders alive today. and countless other arthropods you couldn't even name, waiting in the swamps, in the forests, in the dark caves for anything brave enough to show itself. The Earth back then wasn't an animal paradise, it was an arthropod slaughterhouse. And your ancestors, those early proto-mammals, lived every day doing just 3 things: hiding, hiding, and running. They didn't dare come out in daylight because dragonflies patrolled the skies. They didn't dare surface from the ground because at any moment they might run into a 2-meter centipede. Their only survival strategy was to get smaller, more invisible. For 50 million straight years, they were the most humble, lowly creatures on the entire planet. But history is always full of irony. What killed these giant bugs wasn't some heroic mammal counterattack. It was an environmental shift they could never have understood. At the end of the Carboniferous, oxygen levels in the atmosphere began to fall. The reasons were complex: changes in plant communities, massive volcanic activity, shifts in ocean circulation. As oxygen dropped from 35% down toward 25%, the giants that had once ruled began to suffocate. That's not an exaggeration. In a low oxygen environment, an insect's tube-based breathing system loses efficiency fast. The bigger the body, the more oxygen it needs, and the faster it dies. Meganeura's wings could no longer support flight. Arthropleura's body could no longer sustain its metabolism. They weren't hunted to death. They were slowly, quietly smothered. This slaughter dragged on for millions of years and finally reached its full and final end in the Great Mass Extinction at the close of the Permian period. That extinction wiped out 96% of marine species and 70% of land species. The age of giant bugs ended without a sound, and those little rats that had spent so long hiding in the mud, they finally dared to lift their heads. You know the rest. Dinosaurs rose, mammals crouched in the shadows, then an asteroid slammed into the Earth. Mammals took their turn, and finally you showed up. But the foundation of all of it was that single collapse in oxygen. If that collapse had never happened, the dragonfly's descendants would have kept getting bigger, the centipede's descendants would have kept getting longer, and mammals would have stayed forever at the bottom of the food chain, pitiful little snacks. The reason you get to sit at the top of that food chain, scrolling through videos on your phone, isn't because you're so impressive. It's because the composition of the air 300 million years ago saved you. But now here's the problem. Humans are changing the composition of the atmosphere. Over the past 200 years, the carbon dioxide concentration in the air has risen by 50%, and oxygen levels are slowly falling by roughly 4 parts per million each year. That number sounds tiny, but what happens if it keeps going for centuries? Nobody can say for sure. And here's what matters more. Our understanding of the Earth's climate system isn't nearly as complete as we like to think. The giant bugs of the Carboniferous never saw the oxygen drop coming. The dinosaurs never saw the asteroid coming. And here we are, burning coal that's 300 million years old with one hand, while triggering atmospheric changes whose consequences nobody can predict with the other. Some scientists joke that if oxygen levels ever climbed back above 30%, the insects might start growing again. And by then, the cockroach in your kitchen could grow as long as your arm. The mosquito could get as big as a sparrow. That's a joke, of course, but what isn't funny is this. Our grip on this planet may be far weaker than we imagine. On a geological timescale, humans have existed for the blink of an eye. Those giant bugs ruled for 50 million years. So who is the real master of this planet? That question might not be one we can answer yet. Look down at your feet right now. Is there a cockroach or an ant crawling by? You could crush it under your shoe. But understand this, 300 million years ago, its ancestors may have been thicker than your arm. It was a change in the air itself that tamed them for you. And the air, the composition of the air, you are changing it with every liter of gasoline, every unit of electricity, every lump of coal you burn. You just don't know when the bill comes due. That's the story the age of giant bugs leaves us with.